Now, we have another rule named multiplication rule. Before, we had addition rule, special case and general case. When was a special case? Do you remember that? A and B were, do you remember the Venn diagram? We put two circles, A and B, separately on a Venn diagram. Then we call them, they were mutually exclusive. Thank you. But now, I want to give you the general multiplication rule first. You know, yesterday we had the special addition rule first, and then we got the general one. But today, I will give you the general multiplication rule first, and then give you the special one later. In the addition rule, we added two probabilities. Now it is a multiplication rule. Absolutely, we are going to take the multiplication. You know, the dot in the middle, that means the multiplication. So let me make the cross here in the middle for the multiplication. Who and who? Probability of A times conditional probability, B given A. For what? Now and. Yesterday, we tried to get probability of A or B. A or B, we applied the addition rule. But now today, we need the probability of A and B. And now we have to apply for AND multiplication rule, which will be, again, probability of A times B given A. So look at this. Now we have 40 students. Now we have 40 students, 17 males, 23 females. 17 and 23. Let me define the F1. You know, now from 40 students, I want to take 2 students, one by one. So F1 means, the event of F1 means when I select the first students, the students will be female. M2, second students will be male. Can you understand what is the meaning of the FM, the bisex? 1 or 2, the first students, and the second one. And now I need the probability, the joint probability, F1 and M2. So now we can apply the multiplication rule, the general multiplication rule. So it will be same as the probability of F1 times, be careful the order. Okay, look at this. Here is a probability of A, and the second one is the other one, B, given DA. So now I have to plug, and actually now the F1 is the A, so F1 should be given. Then the other one, M2. So separately again, we take the unconditional probability, F1, and then take the conditional probability separately, and then take the multiplication. For what? The joint probability F1 and M2. So let me take separately, one by one. Okay. I need the probability F1. What does that mean, F1? I select the first students, and the first students will be female. How do you think? What is the chance? I select the first female. Now, how many females? 23 out of? Yes, 23 out of 40. Okay, ignore. Yeah, already we got F1. Now, just focus on the conditional probability M2 given F1. Now, for the second student, how many males? How many males? 22. What? Just a second. Say again.
I said
17. Yes, 17. 17 males now out of?
20.
Not 40.
39.
How did you get 39?
Because after the first female selected, she's not in the pool anymore.
See, sometimes we can say this experiment is without replacement. Already I chose one student who was female. She is behind me. She didn't get back. Then now I will select male students out of 39. Except her, 39. It is a conditional. Based on the new sample space. Now I have only 39 students on the seats. It's good? So can you take the multiplication, please, for me? 23 out of 40 times 17 out of 39. 0.25 and 1. Did you get 0.251? Good, thank you. Does it make sense? It's good? Let me try another one. Did you copy? Okay, let me erase it. Okay, now I need another one. Let me say. I need the probability M1 and M2. Can you understand what I need? M1. It's the same thing. Now the experiment is select two students, one by one. M1, first, male, and M2, second, male again. By the general multiplication rule, I can split two parts, M1 times probability M2 given M1. We are going to take the probability, two probabilities separately. Try the first one. What is the chance? What is the probability? I will select the first male. Okay, now how many male? 17 out of 40. Thank you. Times second male. Now how many males? 16. Thank you. Where is the first male? It's behind me. He didn't get back. So now I have a 16 out of 39. Yes. Without replacement. The other one is with replacement. That means he go back. Then how much will be the second conditional probability? 17 out of 40 again, with replacement. But now, this example, 4.21, it is without replacement. Then by the general multiplication rule, we can take the joint probability, M1 and M2. Good, right? So now we can make the probability tree. Here is the first students, second students. It's actually the experiment was to choose the 2 students, right? So we can make the tree. I will try to make the tree here. Okay, so let me say for the first one, always we have 2 outcomes, male or female. So let me say here's a male 1, female 1. M1 or F1. Case by case, we are going to have M2 or F2. So now you can understand what is the meaning of M, F, 1 or 2. Again, after we chose female for the first one, for the second one, can be M2, F2. Can you give me the probability there? I mean here. What is the probability there?
0.1.
Say again?
0.174.
Can you give me the ratio?
You mean the...
No, not that one. Actually, what I'm asking you here, it is the probability, just M1. Just M1. What does it mean? Select first male. 17 out of 40. How about here then? It should be just F1. How many females for the first case? Very first? 23 out of 40. How about here then? Be careful.
16.
Say again?
16.
16 out of 39. Thank you. It is a tree. It is a tree. So here we knew who was the first student. So the second one, the second column, it must be the conditional probability. Then how about the second one? So now I can say it must be probability M2 given M1, right? And how about the here then? We knew a male was selected. So now, how many females? 23 out of 39 again, yes. The next one, we knew a female was selected. So now, how many male? 17. Now we have a 17 male out of 39. And the very last one, again, we knew a male was selected. So now, how many I'm sorry, what did I say? Wrong. We knew a female was selected. So now how many females? 22 out of 39. So now I can say the event should be M1 and M2, M1 and F2, F1 and M2, F1 and F2. On the tree, we suggest all combinations. Male, female, male, female, male, female, male 1 and male 2, male 1 and female 2. So 2 by 2 is all 4 cases. And then finally, we can take the probability. We can take the joint probability. We just go follow the trees. The very first one, it was a 17 out of 40 times the conditional probability, 16 out of 39. The second one, M1 and F2, yeah, from here, 17 out of 40. Then let's go here and then down to take the female. (23 out of 39 times 23 out of 39. Next, just go through the path. Go down, take F1, 23 out of 40 times, go up, 17 out of 39. And the very last one, go down, 23 out of 40, and then down again, take 22 out of 39. Uh-oh. Can you give me the multiplication? Can you give me the answer? 17 out of 40 times 16 out of 39, please.
0.174.
0.174. And second one?
0.251.
0.25 and 1. Next?
0.251.
0.1251.
251.
0.251.
Yes.
Okay, sorry. 0.251. And the last one?
0.324.
0.324. It is the tree diagram. And sometimes we call it, this one is a probability tree. So when we make the probability tree, the tree diagrams, then we can suggest all cases. The all cases. The very first one here, here was 17 out of 40, and the second one was 23 out of 40. That is the first part, unconditional probability. Can you sum up? Please sum up the two probabilities, please. How much will be? 40 out of 40. 1. Why not? At the beginning, we had 40 students, 17 male, 23 females. We choose one of them. Why not? Yeah, we have to sum up. It must be 100%, right? Just a second. Let me make the space here. No. The first one, yeah, here and there. The first one was 16 out of 39, and the second one was 23 out of 39. Am I correct? Can you take the sum of these two, please? 16 out of 39 add 23 out of 39. How much would be? 100% again. Why? After we chose male, we had 39 students. And now, male or female again. So remained 16 males or still 23 females out of 39. So when we sum up the two probabilities, it must be 100%. And the other two, it was 17 out of 39. It was 22 out of 39. Sum up. 100% again. The same idea. After we chose a female, now male or female. So now I can say, sum up these two, the very first two, 100%, and the second two here and second two there, separately, 100% and 100%. One more. Why don't you add up the four probabilities at the end? Try it. Yeah, even you can expect how much it will be, but try it. How much do you got? Not yet.
I got 1.
You got 1? Yes, 1 again. So the very first 2, and the second one separately 2, and the last one, they are all 100%. Yeah. So when you finish, when you complete the probability tree diagrams, then you can check by yourself.